to just do this in two parts now, starting over. My du would be a dx. And then my v, what would my v be? It'd be e to the x. Yep. Okay. So now I plug this into my ultraviolet voodoo framework, and I get x e to the x minus e to the x dx. And looky there, this is actually a pretty easy one, isn't it? You just end up with this plus c. And by the way, as you all know, with any of these antiderivatives, if you ever questioned and said, does this even work? Couldn't you just find the derivative of your answer and compare it to the original? Check it out. This isn't that bad. If I was going to do ddx of that, watch what happens. I've got to do a product rule on the first, so it'd be 1 d2 plus 2, and d1 would just be 1, right? Minus, what's the derivative of e to the x? Derivative of c would just be 0. You notice how these two just add right out of there. And look at it's your original integrand. So you could always check this by doing a derivative, and hopefully you, in the end, say, hey, it worked. Hopefully you wouldn't get more confused because it didn't work. So, what do you guys think?
It's not that bad.
It's not that bad. Okay, so number 4, your opinion on not that bad might change. I don't know.
I think it's right. I think
It was crazy.
I think
It was
that's
so much
right.
fun.
Wait, do I have to
No,
do
I
another?
switched with your sign versus that.
So, do you remember what I'd referred to earlier on the first two? Listen up, please. On the first two, I referenced a death spiral in which you notice that the, listen up, please. The death spiral happens when the polynomial's degree just goes up, 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 and there doesn't seem to be an end to that. If you do this one right, you're going to get to one of these places where you're like, is this death spiral thing that's not going to work out? But then you're going to notice that the degree of the polynomial is not going up. It's actually dropping, right? And so that makes you maybe think that there is an end to this. So follow the pattern that I told you. Since the transcendental is not ln, make your u the polynomial. Okay? Try that out. I'll catch up to you, and I'm going to try to time this right. We got 12 minutes, and I definitely want to show you number 4. So I'll give you a few minutes here to get to a good place. I'll try to catch up to you. I don't need that much time to do number 4. Anyways, please try example 4. Forrest, did I answer your question from earlier?
I was looking at the other question. I thought we were doing that.
Sure.
I used the function where here is times derivative of L and X, but you said we can't find derivative of
Antiderivative.
Oh.
Right? So
Okay.
so if you make your, hold on,
Wait, Logan, do you have to do this?
u is,
No, this is not right because
yeah, so your u would be ln of x, so your du would be 1 over
You
x.
could lose some sines and cosines.
Okay.
Yeah.
Or neither.
So you'd be, so it'd be 1 over x cubed times 1 over x dx.
It gets going real quick.
Of course, this x would divide out with one of those, giving you 1/3 x squared.
Yeah.
Once this and this divide out, which is it for you would be
Okay,
the
yeah.
antiderivative. Yeah.
So I just write.
I would encourage you to write out the whole box. I
So-
feel like down here you only wrote out a little part of the box. Write out the whole thing. Your
Okay.
u, your dv, and then your du and your v. Yeah.
Okay, like the like that.
No, you don't need that necessarily. Oh, you could. Yeah, you could do that if you want. And then up here would be like the regular function. Your u would go up here. Your dv would go there. This is just a graphic organizer. If you looked at other books, they might organize it slightly differently. It's just a way to do it.
Okay.
That's the way
and
that I
I
like
just
to do
simplify it.
And then just find your antiderivative,
Okay.
and you're done.
And then if it's not logarithm, I just do the normal one here.
Yeah, set it up. You'd set it. You like if there's not a logarithm involved, always make your u the polynomial factor.
Okay.
If there is a logarithm involved, make your u the logarithm, and then the other the dv would be all the other stuff with your polynomial.
Okay.
You're welcome.
Here we go. I'm gonna resolve.
I'm going to do the first part of this here, so feel free to look if you want. That would be my first setup, and I'll at least get the ultraviolet voodoo set up. So take a peek at the screen up there. If your first effort looks like mine, I think we're on the same page. Does that look okay? So let me just ask you guys this real quick. I want to make sure, I really want to do example 4, or the easy version of example 4. When you got to this stage and you looked at trying to find the antiderivative of that, the voodoo part, did you recognize you had to do
Yeah.
another one of these integration by parts? Okay. And then a few minutes later, did you see that you had to do it again?
Yeah.
Okay. So
It's never gonna end.
it does end. It definitely is going to end.
Wasn't there?
So I'll kind of slowly progress through this. Does that make sense? Check it out. So then if you're going to go this way, du would be 6x dx. V would be negative cosine of x. You got to be really careful with your pluses and minuses in here because there's a lot of them and they can get lost. So here is, I'll try to color code this for you. Here is my answer line so far. It's going to be x cubed sine of x. That is coming from right up here. Does that make sense? Okay. So that's right there. And then it's going to be minus, and I'm going to have a whole new ultraviolet voodoo. So this would be negative 3x squared cosine of x minus voodoo. So that would be negative 6x cosine of x dx. The minus would be plus a positive. And maybe you can see now, after I'll simplify this, I'll go back to blue to simplify this. There is now another integration by parts that needs to be done, correct? And isn't it the last one? Thank goodness. Okay. So here we go. I'm going to come up over here, and I'm going to say for that last integral, my u is going to be 6x. My dv is going to be cosine of x dx. My du, and this is the magical part, my du is 6 dx. No more variables in the du, right? That means we're going to finish this. Yay. V is equal to sine of x dx.
Do we have to do the whole thing in the test?
Let's not talk about stuff like that right now.
Wait, wouldn't it just be sine of x?
Wouldn't what be? Hold on. You said it. What?
Not sine of x.
Oh, no dx. Sorry. Yep, you're right. Okay. Okay. So then here's going to be my final push to the answer. I'm going to include these two terms in my answer. So it's going to be x cubed sine of x plus 3x squared cosine of x minus, and now I'm going to do my final ultraviolet voodoo. So this will be 6x sine of x minus voodoo would be 6 sine of x dx.
Yeah, we lost the side bit.
Shoot, you were right.
Okay. So then I think my final, I'll try to get to a final here, would be x cubed sine of x plus 3x squared cosine of x minus 6x sine of x, and it'll be plus 6 cosine of x plus c. So this, in the blue box, would be it. So guys, hey, listen up. Here in a minute, I'm going to show you how this could be done in 60 seconds or less with minimal stress.
Take out your calculator.
I'm going to pretend you didn't say that, Forrest.
Ask your teacher.
That's beyond weak.
Look it up.
That sounds like something someone without any courage
Photo math.
or work ethic would say.
Is that me?
I'm saying it sounds like someone who would say that. I'm hoping that that's not you. Okay. So, Logan up there was like, I think I see a pattern, and then he was like, oh wait, no, it's not there. You partially did. Did you see how the x cubed? Hey guys, please look. I'm about to show you the easy button. I'd love it if you would pay attention.
Oh, I think I see.
Do you see how the polynomial just clearly drops like derivative? Like the derivative degree goes up, and so it just gets simpler and simpler as we go. There's like the plus, plus, minus, plus thing, and how does that all work? And clearly it's going sine, cosine. You would have to think that there's a pattern here. And of course there is. So I'd like to show you that pattern. You have that answer down? So check this out. So the pattern could be more easily done by something called tabular integration. When would you use this? I would say you would use this if you can notice that you're going to have to do multiple cycles of integration by parts. If you look at it and say, whoa, I'm going to have to do this 2, 3, 4 times, then this tabular integration thing, which will work no matter what, this would probably be the better choice. So here we go. I'm just going to set up a little table here. So I'll go with a line like so, and another line. This over here, I'm going to label this ddx. Over this, I'm going to label this, or the other side is going to be an integral. That's telling me what I'm going to be doing. And then what I'm going to do is I'm going to put my polynomial in the left column. I'm going to start it off here, and I'll put my transcendental, which was, what was it, sine or cosine? Cosine. I'll put that over here. I know we only have 2 minutes left, but that's really all we need. Check it out. I'm just going to do my derivatives all the way down to the bottom, like so. And then I'm going to do antiderivatives on the right side all the way to the bottom. So what's the antiderivative of cosine? Sine. And the antiderivative of sine is? Negative cosine. The antiderivative of negative cosine would be? Negative sine. And then off to the left, what I do is I go plus, minus, plus, minus. I just put those little alternating plus, minus signs out to the left there, and here's how I get my answer. Check it out. Just multiply along these. Oh, I need one more. Sorry, this last one would be positive cosine. I just multiply along these little lines, and I'll have my answer. Check it out. So the first one would be x cubed cosine of x. The next one would be plus. Oh, sorry, the sine. I got off on my lines. Thank you. X cubed sine of x. A negative times a negative is a positive, so it would be plus 3x squared cosine of x. And then the next one, a positive times a negative is a negative, so it would be minus 6x sine of x. And then the last one, a negative times a positive is a negative, so it would be minus 6 cosine of x. Then don't forget, after all that, you're plus c, right?
It's
very, very
it
nice.
always alternates plus minus on that left side.
Yep. Yep. So if you just multiply along those like little bent lines, you'll get all what you need. All right. Hey, that was almost perfect time.
I had something.
You did. You saw part of the pattern. You did. You for sure did. It was good. Basically, you saw the left side of the column.
Yeah, that's fair.
Yeah. All right. Have a wonderful weekend. Remember, there's no test on Monday. The Unit 3 test is on Wednesday. So, have a wonderful rest of your day and weekend, and a happy homecoming.